I don't have an easy task because I know that we have small delay, and then I'm the last one before the lunch. So yeah, it's always strategic positioning, so it's super nice. But let me guide you through the batteries, the space of solid-state thin film batteries that I'm representing, and I'm happy to be with you today. I will take you like 15 minutes, then we can go for lunch, and for those who will be more interested, I'm here, of course, till the evening. And basically, what I would like to cover today, to present you what we are doing in the batteries, because we're producing thin film batteries here in Poland. And why I'm happy that the panel before touched the issue of problem with mass manufacturing, costs, equipment, so I would be happy to touch these topics today. But let me grab the issue of the thin film batteries. What is the problem? Because thin film batteries, of course, existing decades on the market, but they didn't find still a massive adoption in the wearables, beacons, IoT, a mass market. Why? Because simply of the cost of production. Today, a cost of production for thin film batteries is super expensive because the current technology, which is magnetron sputtering, it's very expensive, requires high energy. The equipment itself is super expensive. Also, the substrate, it's expensive to prepare because they need ceramic targets for the sputtering technology, which is very expensive. And that's why simple, because of the technology, the technology is not there. We don't find these thin film batteries in our cell phones, wearables, iPods, earphones, and basically in this market. And here we are, the batteries. What we did till many years of research, R&D, we developed, patented, and also tested our technology, which is basically enables us to produce the same thin film batteries 100 times cheaper than existing technology. We believe that because of this factor, we will be able to penetrate the market of beacons, wearables, sensors much faster with the technology, because this is not only idea. We just tested this. We have independent tests from the different R&D centers like Cambridge Institute, where we send this. We've been testing the technology and also has a confirmation that the technology is working. So it's not only an idea. And with this, also maybe a couple of words about thin film in the nutshell. Why thin film? Because I don't want to go through the very technical slide, but in principle, I would like to highlight two of the key important points. The thin film batteries are basically much better designed than lithium-ion batteries. And why? Because, of course, the thickness of the battery itself, it's a major advantage, I would say. But also, due to the structure of these batteries. As you can see here, we don't have liquid electrolyte at all. So basically, this battery, it's super safe. It's not flammable. It's not expanding. You don't need to leave a space in the watch or somewhere for only swelling of the batteries, because basically the structure it's a thin layers. It gives an enormous advantage for different application in different industry, and I will just comment this a little bit more later. In terms of the more advantages, what I highlighted also very important is discharging cycles, because basically you can see that this battery, it could be even lifetime. 10,000 charging cycles, it's super normal in the thin film battery solid state. We have in our laboratories a battery that we are already testing 30,000+ cycles, and the deterioration is 5 to 7%. It's super low. So that's basically, and then we keep continuing discharging. Time-wise, you can charge this battery in 6 to 8 minutes. So it's also super important for many applications. Also temperature range, it's like this battery is working in the -40 to even +160, +170. We tested this independently on the temperature on -20, and it was super working without any technical issue. And what is on top, I would say the combination, what I highlighted, it's a thickness, but also we can produce a tailor-made batteries, so different shape. So we don't have only this shape, this size, like here you see on the picture. We can just design the batteries for the specific designer needs, different shape, size. So this is also the technology that we are working. It enables us this, customization in this area. Okay, so this is in terms of the batteries. The product sheet, I will be happy to send you this presentation, or you will have this in the materials, so I will not cover this, but I would like to give you just a physical example that I think is super concrete. This is Apple Watch 4 with this battery dimension, as you can see, and what I put here, it's a combination of current technology, so current battery you have on the left side, lithium ion, with all this energy density, charging time, 50 minutes, and cost. And basically here in the middle column, you see current technology of thin film batteries, current magneton sputtering technology, and us. Of course, in the technical parameters, it's the same, where we are matching, but the most important is this one. The cost, what I highlighted at the beginning, our technology enables us to put the product on the market in the cost of 100 times cheaper than the existing technology today. I think this is, very appealing. And on top, on the cost, it's of course the most important in terms when we talk about mass production and scaling. But I would say also today in the environment issue, it's important to highlight that technology that we are using, it's using much less materials. I think in terms of sustainability, ESG, it's also important to highlight this, that except of the cost, we basically to produce final products which is the same that currently existing TFB, we use much less materials in our production technology. Okay, so just to sum it up, the technological aspect, to give you a snapshot of this technology. Of course, current competitors and us, we developed the technology that is 10 times cheaper in terms of the cost of materials. Materials utilization was what I just highlighted. It's much better. And on top, those two parameters that you can see here, is the most important, I would say, in scaling and mass productions, which is, cost of energy, it's 10 times lower, and also equipment for the building factories, mass productions, it's also much less expensive in our approach than currently existing in the market. And of course, this is not theory. I'm not showing you only, idea, engineering concept. This is, in reality, because we just tested this. This is, our pilot line. We just complete TRL 7. We are approaching TRL 8. We have a completed production line. This year, Q4, we are starting producing the batteries in Rzeszów in Poland, in the technological park. This will enable us to reach maximum capacity of 2 megawatt hours a year, which is basically a couple of millions, potentially units a year of final products. And where we would like to apply this, we are not hitting the automotive market, of course. This is, I hope it's obvious from the previous slide. So we are addressing wearables, beacon, different sensors, RFID tags. This is our area of interest right now with this. Why? Because we believe that those segment is super fast growing, not addressed right now. And the whole market for those financial investors that are today with us in the room, it's worth highlighting that, of course, I don't need to convince you today that the battery market is growing everywhere. There is a high need for the batteries. But even look for these parameters that, the 5 billion, it's expected to reach of 27 TFB only with current existing technology, which is super expensive. And even with that, there is a high need for these batteries because of the parameters I showed you before and the advantages that TFB currently possess. And that's why we would like to address those markets right now in the first stage of our strategy. And then, of course, for the financial guys here, some numbers from our company, the batteries. We are completing this 2 MWh production. With this, it will enable us to reach by a couple of years, 27, a quite high EBITDA margin, we believe of 70%. And this is the numbers we believe we will be able to reach by 28, 30 million EBITDA with the investments we already made in the factory in Poland. But of course, why we are here presenting this concept to you guys? Because we want to expand. We have big ambitions. We look also right now for partners who can help us to scale, build bigger factory. Our next stage is we want to go for Series B, build a much bigger production facility, which with output of 20 MWh a year. That's our initial plan. And we look also for strong partners to help us to build a global brand and also marketing and sales activities, because till now, 95% of our team is engineers, PhDs. Why? It's like we have this experience, because I have to tell you, in the battery space, we came a little bit with the whole team a backdoor, because the team has huge experience in the mass production. We've been building equipment in Asia for big manufacturers, for Apple, Samsung, LG, TPK, in terms of the hardware equipment, because we are experts in the production techniques and production technology, basically in deposition. And with this experience, we brought this to the batteries, thin film, solid state. And yeah, we patented the technology, and right now we are scaling this with the sales operation and more activities in the next rounds. And yes, with this, I would be happy to talk with you if you have interest in the product. Of course, we will be happy to talk and answer all the questions. And also, if you are potential investors, we will be happy to talk with you, have a chat, to present you our roadmap, where we are going, what's our need. Because, of course, this is not that we know everything and we conquer the world. There is also a lot of space that we need support with strong, experienced partners that are today in the room and also online hearing us. So thanks a lot. If you have any questions, I will be happy to answer, because I think we have 2 minutes. Yeah, 2 minutes. So if there's a question, I will be happy to answer. If not, I would not keep you, of course, before the lunch. I will be happy to answer the questions after all. Thanks a lot.